We're going to balance this using the algebraic method. First, put down variables A, B, C, and D because we have 4 chemical species. You're then going to create a linear equation based off of the quantity of each atom type. Here, phosphorus, chlorine, hydrogen, and oxygen. The equal sign of your linear equation will come at the yields or produces arrow. There's 1 phosphorus associated with A and 1 associated with C, telling us immediately that the coefficients A and C will be equal in the future. We do the same for chlorine, hydrogen, and oxygen. Once we have our linear equations, we simply solve for each of the variables. In order to do this, we'll set one of our variables equal to 1 and solve for the rest. We'll make adjustments at the end if necessary. For this one, I would choose A or C. The reason is both of them have the highest coefficient in the linear equations. The other is they both tell me a lot about the other things. A and C tell me about each other. A tells me about D, and C tells me about B. We go ahead and we set one of them equal to 1, solve for the rest, and we get our coefficients. We can do the same using the more traditional method, which is a trial and error sort of method. Because it's trial and error, it's not as good as the algebraic method. However, there are many times that it doesn't take very long to do, and so it's good to have this in your arsenal of approaches. When we do this, we typically set up what's called a wrap table. The reactants on the left, the atoms in the center, and the products on the right. Setting up this table immediately allows us to see which things are equal or balanced and which things aren't. We can then go ahead and put in coefficients into the chemical equation so that we can balance it. You need to be careful. You need to be careful that you're tracking everything, especially things like oxygen or hydrogen that may exist in multiple locations. I'm also going to show that the wrap table and the linear equations are virtually the exact same thing. The biggest difference is the linear equation has variables and an equal sign. Other than that, everything is there. The other big issue that happens is things like hydrogen, where we have hydrogen associated with C and D. In the wrap table, we simply add them together. In the linear equation, we see them separated, but if we added all of the coefficients together on the product or reactant side, we would see the same quantities exist. So here, 3 plus 1 equals 4, rather than simply stating 4.